Okay, so in the sense of Rosetta Stone, I don't think I need to define what is Rosetta Stone. Anyone? If anyone, please raise hand. If oh, acha, okay. So Rosetta Stone is a multilingual, actually trilingual stone found is for Egyptian hieroglyphs. So which is a main crucial part of decipherment. It's written in multi languages. First, it was hieroglyphs, Egyptian hieroglyphs. Second was democratic, demotic. Okay, and then the old Greek. So point is, it helps to understand, because if you don't know anything, a particular language, and you know some language. So suppose I have given you, if I'm giving you Hindi with Tamil, at least you can, maybe you can guess it. That's how it's helpful, and it's most of the cases it's very is crucial for any decipherment. So very recently we actually so very recently we met Mark Canoyer. So I was casually he was here only Chennai. So I asked him that I asked him, what do you think about decipherment without this? So he said, unless until we get Rosetta Stone, it's meaningless. So is it, whether his statement is correct or not, it's you can up to you. So but we take a different approach. So a counter example is, yes, it's very crucial, but counter example, we know that linear B main point was the computational aspect of it. So we can discuss all these things so a different way. We can say that, okay, in absence of, if we don't have that evidence, this kind of evidence, if we have, so then there is obviously it's easy, we can understand. In the absence of it, what can happen, what one can do, what we can do, what you can do, because anyway there are many, okay, I think every month you are getting some news that, okay, somebody has anyway deciphered. So but and it's not one time, it's multiple times had happened that, okay, many people has claimed that they have deciphered, but in general in the mass is not accepted. Why? And when we been involved, what is our approach, what we thinking that, okay, how we should take this forward and how we will take these problem. So what is our goal? Our main goal here is to develop a computational tool. Instead of decipherment, we are not directly involved into getting the meaning of it. So instead of into the meaning, because that is really subjective area, it needs a different aspect of it. So we are mainly focused on the development of a tool which can help or support decipherment. How it can be? Maybe so our I think, yeah, so this is how we do in the absence of this is how our general approach. So in general we meet people, we discuss, we do something else also. I think I have some secret packet. We also do these things. Okay, so yeah, so so for us, when we, so this is anyway, these are the data. So once we are having this kind of data, so there are many there are people who has already organized these information, because our concern is mainly this portion. This is the inscription portion. So this portion anyway, there are people, Hunter, Papula, Mahadevan and Bryans already they have organized this in a digital form. So, we are working on these things. So, Brian Swells actually visited here in 2008, I think. So, when he was developing his database, so we worked with him. So, and finally, so right now we are working with his database, which is more comprehensive and these things. So, yeah, so our starting point is, instead of looking the focus, what we do first, since our focus area is this, we have converted every sign into a particular specific symbol and given into a specific number, but this number is done by this Brian Wells. You are following his things. So, what he has done, okay, maybe I will just write it down. So, let us say let us say there is some sign, just okay, I am just randomly drawing some sign. Let us say this sign, okay. Suppose randomly hypothetically doing this. So, what he has done, he has assigned each sign into a different unique number. Let us say this is S740, this is S, I think 209, 3-digit number, 220. I think 540 something. Okay, fine. Let's do this. Just keep remember this. I deliberately have written for some reason. Okay, so now our concern, when we are handling, our focus area is this. Now we are ignoring just to make to save our computational time. We are focusing into that. Just is simply that, okay, instead of writing ABC, we are reading it 1, 2, 3 up to 26. So once we are getting this, so just as Bhaskar said that, okay, proximity. So we are saying adjacency here. So based on the close proximity, what we are doing? So okay, if there is if two signs are occurring side by side, we are saying, okay, just connect it. So based on that, we are making a matrix. This is called adjacency matrix. So these are some specific procedure. We just ignore it. So, and based on that, we are creating a network. So that's how we start. This is our way of starting the problem. We start with we got this one, and finally we end up with adjacency matrix. This is the visual representation of network, and this is the computational way of doing the network computation. That's it. So that's how we start. And once we got the first thing is that, okay, what to do? So for so first thing what we did is that we took, since we got a network, so it is fine. Let's see, because if you will see the number of signs a lot, as you might have noticed that, okay, here in the list is roughly 700 signs. Even if you will see that Ravathan's 400 signs, it's a lot of signs. If a person who want to focus in their study, it's very hard to look at all the signs at a time. So can we classify? The question was that, okay, can we classify these signs in some category, some basis? Is there any way? So we use very well established technique in the graph theory technique in computer science. So we use K-code decomposition. K-code decomposition is very simple technique where you saying you have a network, and those network combination came just because of this close side by side occurrence, because of side by side occurrence, because two signs are side by side. So each sign is a node here, and if two signs are occurring side by side, there is a link. if you will club all these things, finally you will get a bigger network. Once you have a network, this is your full fledged data. Once you have a network data, what do you do? And that full data we are saying here by definition is that at least in our network, if suppose some node is having no connection, suppose our sign is appearing alone. So somewhere there will be one node there is no connection with. So we are ignoring that because there is no point of reading relation to that. So if here in the network every sign has at least one connection, so that we are saying this is the one core. Then the technique is saying just remove all those nodes and keep it somewhere, and it is a recursive process because if you will remove this and you will get again, and finally you will reach a sub network where at each node is having two connections. So this is called two core network, and you can go on and you will reach in a level where if you will remove further node, the whole network will destroy. Okay, that we can say the 3 core or the inner core. In this course the 3 core is inner core, otherwise you can go on. So why we did that? So those those were part of first core but not 2 core. We are saying this is a cache, the shell 1 node, and then those were part of 2 but not 3. We are saying the node the 2 shell nodes, and so on. So when we did the same thing in case of Indus, we reached up to 14th level of core. So maybe this is for you. So what we found, the interesting pattern is, so first what we did, so we classified the all sign into distinct category. Okay, what is the importance? What we found it, this is the finding, but if you will correlate, when we start looking at the pattern in the sequence, we found the signs which were belongs to the outer core, the first shell, the outer, the periphery. Okay, we also call the first shell is the periphery. Yeah.
Are there any high frequency signs in that outer core?
Yeah. Okay. Almost not. Okay, that's what I'm trying to say. That's why you say especially.
If there is one, it is interesting.
Mostly not, but yeah, it's not 100% true, but mostly not. So the behavior is this: the signs which appears in the periphery, they are very much restricted in their position. Either they are terminal signs or they are associating with very limited number of signs, which you can see. Yeah, exactly. So and see, this is not only you should not restrict with the frequency itself, because this is giving you the advantage that in terms of connectivity, because that is more important in linguistic. Maybe frequency is not telling, will not tell that much what is saying here, because it's saying, yeah.
When you made the network, did you consider both neighbors or either?
Yeah, it's for okay, this result is for undirected one, but it's a directed, yeah, same.
Even if it's undirected, you took both.
Yeah, undirected is so you don't need to consider, right? You are saying.
Right. Then at least all of your nodes.
Oh, sorry.
Degree 1.
No, sir. This one is sorry, directed one. Yeah. Okay.
Left or right?
Left or right. Yeah.
Left or right? Which would be
Left to right?
Left to
right.
right to left. Okay. Here in our case, that we have shifted it, but it is right to left. The way it's because I'll tell you about the direction also. Okay. So it's that way. So the point is.
So sorry, for number 2 there are only 3 or 4, 5, 6, 7.
Yeah. So okay, since it's also because the length of the sequence is normalized. just because of that. Okay. So what we are trying to say here, see, and this, okay. So what we are trying to say here, so if a person want to write a grammar of the subject, they should focus sign belongs to the inner core, this portion, not into this one, because maybe these signs are having the nature of connecting with anybody, anywhere in the okay, with anybody in the sign list, as well as anywhere in the sign sequence. So they might follow the general rule of grammar, but to explain these signs you may need kind of some exceptional rule.
So 11 connectivities is the minimum, or 10 connectivities is the minimum? See, the outermost is 1 connectivity.
Yeah.
Purple one is 2 connectivity.
Yeah. So this one is, I think, 14 up to the here.
Up to 14.
Yeah.
But after 10 it becomes significant, isn't it?
Yeah. So just here, because a lot of overlaps. Yeah. So you will get, say, yeah, this section is a,
Light green is the circle.
yeah, you can see that either these 3, or you can just take it, yeah, these are the things, you can just take this portion. Sorry?
What is capital and
Total number of signs.
Total numbers. Just
But 13, 14 is significant.
yeah, this is significant.
The core of the writing.
They are core. That's why I am saying this portion is this core of this thing. So if you will take this chunk, you will get enough percentage.
And that 14 shell is exhaustive.
Yeah, all are. After that, if you will remove, the whole network will collapse.
Yeah.
So that is important, especially when you are planning to write a grammar, because for sure these are the exceptional signs, because either they appear only one case, they appear only as with specific association, that's it. So this is our way of approaching.
This is all
Yeah.
on the Wells sign list.
This is well said.
Yeah, well, scientist.
So
Is
Mahadevan
this
had
also
that.
produced for the Mahadevan sign list?
Sorry,
Is this also done for the Mahadevan sign list?
I have done that, but in my publication I had used this one, but yeah, it's
As a matter of comparison, so how many outer rings does that produce, and how many inner cores does that produce?
see, number of, yeah, for sure, the number of core will be different, but the nature is same. See, here what I said, in this case, in the example case, only 3. So what I am trying to say, just plot the graph and just ignore this outer one, take only the inner one. How many inner you want to consider based on how much constraint you want to put in your grammar. So here it is very clear in this case, it looks like that, okay, somehow it's gone almost close to 0, and then this is the bulk.
No. So Mahadevan
Yeah.
had the sign of the double diamond, which used to go with 99.
Yeah, exactly, that's why I am saying, see,
Which is that sign here?
uh,
I don't see that double diamond sign in the 14 shell. If 99 is there, 342 or 243 or whatever the rest of it there.
maybe that comes in the 13th cell, maybe it's possible. So here okay, it all depends. Well, we can check it. That's not an issue. So the point is, what we want to say, you can just look at this. For his double diamond, I don't remember exactly.
99 had 342 99. That is what the reason.
Yeah.
And does it use all of the corpus of 5,538 objects, or do you have you subdivided the corpus in some way?
Okay, we have, for our study, we have only the sequence which is complete, single line, that's it. We ignored all the broken seal, we ignored which is having double line.
Or you ignore the sector?
Yeah, broken, suppose a sequence is in broken stage, we haven't considered. So yeah, so that we can make it,
What about those that are in 2 or 3 lines but are complete?
no, we didn't. Single line complete. This is our answer.
Do you at least take the second line and third line as a separate unit?
No,
And
no. In this study, complete single line and complete.
So when you take a single line, the preference is to the top line or the bottom line?
I didn't consider.
Oh, the whole thing.
Yeah, seal, single line complete, so that no question, no subjectivity, that's it.
So how many objects does that leave you with out of 5,000?
Around 4,000, roughly 4,000. Yeah. Okay. So this is from this study you can come. The conclusion is we can divide signs into number of disjoint categories, which is not only differ in term of frequency, it also differ in term of association.
Significance.
Not okay. How do you want to define significance? It all, but what we are saying is association.
Yeah, importance
Yeah.
is the word.
Yeah. So the issue is the whole issue with the Indus is we have a very limited data. We don't have much data. As I said, there are only 4,000 sequences we have. If you will say the unique list, only 2,000 list we are having. So the point is, since we don't know the history of the connectivity and the history of civilization, so it's very rare, very problematic when you are inferring anything or with limited data. So what approach we are doing? So in what we do, we are taking data from the known linguistic, known linguistic sequences, trying to do our maths with those and trying to find out if there is any pattern, what kind of pattern is available in the known system, because we can understand that easily. Here we can say anything, any jargon, you have to bear with, but maybe people will not be interested, even we are not interested. So the point is, instead of that, at least we can what we are doing, we are approaching as a comparative study method. So we are taking the known system and comparing with finding the any pattern if it is there in the known system and trying to map Indus on top of it, whether is there any similarity or any things on that. So the next next question what we were asking that, okay, for decipherment direction is very important, as you were saying that even in image is having the direction. So but as you said that, okay, there is no standardization, even in a linguistic sequence there is no standardization, because in the most of this known system we know is a left to right direction we read and write. All Semitic languages right to left, Mandarin top to bottom. There are some exceptional example of bottom to up. So the point is, so since there is no standardization, we can't guess. So if we can't guess, how can we do that? Archaeologists try to use the approach of cramping at the end of the seals or squeeze or sometime displacement of the things. That is the usual method. Even before us, whatever before developing our method, it does not mean that people were not knowing. Yes, they were knowing, but advantage is we came up with an objective method of finding the direction. Okay. So the archaeological this establishment of the direction in Indus is just based on 2 or 3 seals which is having some specific pattern. If you will remove all those 2-3 seals from the set of thousands, almost not possible. And one can discuss, one can fight, but no way to establish it. But our method is free from that. How? We can, I'll show you this. So we came up with a very naive approach, very simple things is we took a simple English dictionary, since again I said a comparative study. So we took an English dictionary, kept it in front of us. We simple ask question, 2-3 questions. We ask how many, just ignore this first image. We ask how many words start with A, how many words start with B, and how many words start with C, and so on, and Z. So we got some count. This count is just in probability form, just it, but this is count, simple. We ask the same question for the reverse way. How many words end with A, how many words end with B, and so on. We got another count list, and we just kept the count list in here. And then when we saw this too, can anybody guess what is there anything interesting here?
How big is that data set?
Okay, that is exactly, this is I'll tell you that. Okay, let me so what is this, any guess, any difference, any similarity?
The peak is at S.
Peak is at nice. Okay, anyone who haven't attended my talk? Because I have this explained many times. Okay.
No, delta around the mean is minimum in the upper one, maximum in the lower.
Yeah. Okay. Exactly that. Exactly. Yeah. So the point is, see, if we'll see here, it looks like almost roughly, almost every appearance of every letter is there in the English. In the start, there are almost all letters are there, but here most of the word ends with only few letter. The hypothesis is, when you want to start uttering a word or any sound, maybe you are free to choose anything from your basket, sound basket. But once you choose something of any sound, maybe somehow your vocal cord or your anatomy somehow restricting you to utter something further. It's making you somewhere state. That's a reflection.
Initial choices diminish the further choices.
Exactly, that's it. But initially we thought, okay, maybe it's a common thing, maybe just because of English. Anyway, English is an alphabetic system. Possibly it's not. So since we were having a set of data, we said, okay, let's do that. Why can't we check it? So when we checked it, okay, okay, so so this is just quantification. We can just ignore these things. These are the quantification method. Even we checked these things. Initially we thought, okay, maybe is it artifacts of our method, because sometimes even one method is also can be problematic, because we know that, okay, if you are using mean or median, there is a difference, but fine. So when we tested in a different way, and we found that not is that way. So when we tested different languages, we use hell lot of whatever I can collect from the online resources, roughly 25 things we tested, and everywhere we found that this pattern exists, irrespective whether the writing system is alphabetic, whether it is a syllabic, ideographic, is a current system, old system, doesn't matter. So that is the beauty of this approach, and top of it, we are not using any linguistic information so far, because what we use, just count how many times you count.
You are using only letters, not words.
Any sign,
Only letters.
sign.
In the case of
Yeah, okay,
ideogram.
yeah, it's a ideogram. So it's better to in simple way, any sign, whatever sign you are using.
And in Japanese it's syllable.
Yeah. So so you can use that. Even we thought, okay, let's just to test the hypothesis, we said, okay, what will happen if we'll scramble the whole, let's say we took a dictionary, just scramble the positions, Just keep the things as it is. Let's say a word is watch, keep it watch, WATCH, but just scramble it, the position. What will happen? If one no, is going to 0. So nicely it managed to tell you that okay, these correctly managed to find out the directionality. And once we, so this is the universal pattern we found. Even I do remember that okay, when we sent this paper, and then this our reviewer test was not he himself was surprised, and he tested his own data of his language, and he wrote these things. I tested that, so and it was working. So yeah, so when we established this universal pattern, then we said okay, if everything is working here, if Indus is having any pattern, it should show something, and we saw that Indus is here. It's saying right to left.
Does your result produce exceptions? Because wells and fulls still report 6% left to right.
Okay, so these in his case, they already he has shifted the all those from right to left. He has shifted. So since we are using his data, so that's why I didn't get any issue. But even if you will consider the raw data, it's very far from the thing.
I get 0 for left to right in my own analysis.
Yeah, it means that there is no pattern.
No, everything is right to left.
Okay, it all I don't know how you have.
Mahadevan produces a 7% exception.
Mm-hmm.
That is, he says 7% of the corpus actually is left to right. Brands and wells and fulls in their corpus, they report 3% left to right. And both of them report 7% indeterminate.
How they have come up with the 7% and 3%? Is it subjective?
No, it's based on frequencies.
Okay, I never come up with any of his analysis that way they have come up these frequency analysis for yeah.
But even if they had read it from left to right, in their corpus, I think they would have realigned it.
Exactly. Yeah.
No, they haven't. They're not. They very specifically called out the direction as left to right.
Okay, I'll tell you one thing. Since I'm using Brand's things, and Brand's has worked with here, and he is I work with him, even Subhuta and Sitara is under his guidance that we have done. So I know what he has done for sure. That his thing, I'm not very sure about Mahadevan's thing. Maybe Subhu can say that. But even if, suppose if we are taking the raw form, it is very far from the same. This is our deviation. Even we have changed we have randomly chosen, we have used the bootstrap model here. Even it's saying that our deviation is somewhere here. So it's that much robust. Yeah.
Mahadevan is standardized.
Yeah. Okay.
So, except he makes a marking saying that it's written from left to right. So,
okay, then in that case, I have already tested eBirds because I have already done that. So it is not here, but I have done that. So that is also following this. So even that's what I'm saying. The beauty of this method is, okay, I'll show you some more result. This one. Let's say you take some x size of the data. So this is around 10 to the power 5, 60,000, 70,000 data. Doesn't matter, you don't need that many data. If you will get enough, a small set somewhere 200, 300 in case of niche, okay, you are enough. That's maybe this is your answer. How many, what size you need? You can just take a small size.
The previous slide. In the right, left to right, why is there so much deviation between languages?
Oh, this one?
Dutch, for example, is extreme. Hawaiian to chhod do.
The data size, because we have taken very small data size because resources also. Just because it will take a good amount.
Sumerian.
See, because these are the bootstrap thing. Randomly you are choosing something, so yeah.
Because Sumerian is nearly 0.
Yeah.
Sumerian, Malay.
So we have
No, but the error is almost negligible, so it is significant.
yeah.
No, but look at here. Look at Hindi, for example.
Yeah, but they're way far from the. I mean, if you look at the
See.
basically what you have to look at is the red bar.
No. What I mean is, why some language coming out to be extreme left to right, but some are coming almost left to right.
Okay, so we never done that. This study whether what the magnitude whether magnitude plays any
It's
role.
okay, but look at the Indian English comparison.
Mm,
English is fourth line.
Hindi,
English.
English, yeah.
I mean, per
Okay.
se, I'm not saying it in the context of industry.
See,
I'm per se saying it's an interesting question to ask why English is so much there, why Hindi is there.
okay, I can say it vaguely, but this is not the study. So maybe it's an alphabetic system. You can say that it's a logos play because of it. And data sets is also playing into some role. So, but what do you should consider that okay, whether
The error bar for
anyhow.
Indian English is the same.
Sorry.
Indian English, the error bar is somewhat similar.
No, the data set sizes are different.
No, but the error bar is a reflection of data set size.
No,
No.
it's
So,
bootstrap
for
model.
example, in the next slide, you can see.
So this is that.
So this is the data set dependence on data set
See,
Ah.
size.
this is data size 100.
So I thought the error bar in the previous graph is dependent on the data size.
No, not necessarily. This is only for English. So for different writing systems, the error bar also depends on the type of writing system and so on. The size of the signary. It has a very complex dependence on signary size, database size.
In general, here, okay, yeah, this is look. It's you are one way you are saying it's correct, but not only depend on that way because it's it can depend on other system also. What kind of system it is. Barring that, if you make the system constant, yes. If you are taking a very small data size, the error bar is. No. So my point is, you don't need. So okay, what I was trying to say initially, the previous system, if you remove those 2-3 scenes from the database, you will not come up with the result. But this system is so much robust. If you will give me randomly a few percent of the not few decently a decent percent of the data, we can come up with a result. So this is an objective method. This is objectivity. There is no subjectivity involved. There is no need for the further clarification, and it is or a method is somehow aligning with the archaeological finding. This is what the archaeological evidence is. Yeah, so this is this part. So that's how we try to work here in commercial photography lab. So yeah. So the next. So for further study, what we did that once we established that okay, which way we should read and write. After that, we said okay, let's go to the inside the sequence. How can we do pattern? Can we get any recursive structure? Because see, when we are anything reading or writing, it has its own pattern, and that pattern we are calling grammar. Grammar is nothing specific pattern. So, so can we? And because we know that okay, there are there are many claims that okay, these are not a writing system even. So to come up with the question, we said okay, fine, let's find out if there is any recursive pattern, any recursive pattern is available in the system. So for that we use very simple basic statistics, which is called by using z-score method. I'm just completely ignoring the methods. So what we managed to do that we come up with a complete computational method. We managed to segment a linguistic text into their association. So it's saying that the chance of what is the chance of this a subsequence compared to its random chance. It's saying that okay, if two people are sitting by side by side, whether it's by randomly these two people are sitting here, or is there any pattern in it. So what you can do, you can just check with all the random, you can compare with its randomized probability and its actual probability. Then you will, so this, that way you will get a probability that okay, what a subsequence, how much a subsequence is probable to occur together by its random chance compared to its random chance. Okay, so we found that, so these we managed to segment the known sequences. Again, known sequences mean all the study we have done on the kind of known system. So once we did it, initially, yeah, since it is we can read all these, not all, but ignore this one, but most of the, then we can say, we can easily understand okay, what is going to happen. So what is these, but in the mathematical term, to analyze this, what we so we compute the height of the tree. This is, we convert all these all these segment into binary tree, and the height of the binary tree is saying whether there is any structure or not. If height of this, height how to count, if height from, if suppose these are the, let's say the which one is small, okay, this is small, 1 2 3 4 5 6 7. So take the lowest one is the top node, 1 2 3 step. By using 3 steps you can reach here. Here you can reach 1 2 3, again here also 3 steps. In some cases here is you need lot of steps to reach the top. So if the height of the tree is length of L minus 1, it means there is no structure. If height is log of this, there is a structure. So with this boundary, when we calculate this, we found this pattern which is saying that most of the linguistic system fitting in somewhere in this boundary, neither somewhere in between, not the upper boundary, not the lower boundary. So, but once we got that, so where is Indus? So we found that Indus is somewhere in between. So that is establishing that this kind of method is establishing that these are not a random system. At least the behavior of Indus is very much similar. Very much similar to the actually recursiveness inside the linguistic Indus sequence is very much similar to known linguistic systems. It doesn't mean the decipher. It doesn't mean the linguistic. It means that there is no randomness. There is a recursive pattern available in the Indus system. Okay. So that's how we do our study. So this is overall a general. Okay, I'll try to finish. So this kind of general study we do, but for further depth, what we can do? We can go for further analysis. For this, what we enter into that, okay, what these segments mean, what are the pattern in it. When we plotted these, we found a very specific interesting distribution where especially the power of this is 1, which, okay, this kind of pattern has in linguistic term has a special name is called the Zipf's law distribution, Zipf's law, and Zipf's law is saying that uh, that a few signs are occurred again and again to construct a system. System here is a word because we have segmented the word here, all the words. So it means that all your subsequence to construct a word, you are using similar same unit again and again. So this Zipf's law is also called the theory of minimal effort. So yeah, so this is again in all the we found in most of the cases, not most, all the sequence we found the same pattern. What does it mean? So it means that there is because so far Zipf's law is known for the word at the level of word, that okay, number of word using is very following the Zipf's law. But here what we found, the Zipf's law even is available even in more fundamental level, even in the level of a unit which construct word. Okay.
That is the sign.
That is subsequence, a joint, yeah. Not in the case of any sign level. Sign level is not available. Yeah. So, and then we ask the question. Okay, we start looking how many to make a word. How many segment you required? How many units you required? So what we found that to construct any word, the number of segments you required is very much almost constant. Just 2-3 segment you required to construct a word. Though in terms of your regular orthographic notation, your deviation is very high. The variation is very long. But in terms of unit, it's very constant. So this is again a universal pattern we found. Why it is? What is going to say these things? Does it mean that here anything specific or any phonotactic constraint is playing the role? These are the questions. So it is not the answer. So okay, because we don't know how to interpret these. But since it's an empirical rule, empirical evidence, this is the pattern. So or maybe whether our vocal anatomy is playing any role, we don't know. So this kind of question we are asking. So again, when we are entered into to the in depth, because our whole target for the Indus. Okay. So when we start looking to the motif of the subsequence of Indus, we are finding these kind of patterns. So up now problem starts. There we can find easily. There we found very easily that this, if you can remember, we found these segment. Actually, most of the segments are either suffixes, infixes, or some kind of root words. Here we could easily find out because we have evidence. We know that. Here we don't know. Here we don't know what are these. We can guess it, but we can't do it. So for that, what we need further more information, contextual information. Maybe we need to know whether this particular pattern appears mostly in the poetry, scene, X, Y, Z, Pinigate.
But that's available.
That's not available.
Especially in the Wells corpus.
Have you, okay, how many of you are having good experience with Wells database, and there, okay, the images are not available, right? There they have constructed their own version, right? Suppose if you agree with Mahadevan's database, you won't like that. The problem is, I'm not saying problem, this is an issue. They say like this, if you'll see this sign, Brian will say this is one sign, Mahadevan will say is a two sign. He's saying this is jungle, this is two tree, that's it. Sometime you maybe agree with this, sometime you will you want to look your data in this way. What will you do? You can't say someone is wrong, someone is right, but there is difference. And if you really want to see these images, image is not available anyway. This is not in his one. What is available in his database is this.
No. I think now that he has started to add a lot of images.
Now.
Yeah, he's added images, but that's not the that's not the issue.
Okay.
Yeah, they have uploaded the images. God knows from where they got them from.
No, they were waiting for copyright permissions.
Yeah.
And I think some of them have come through,
Yeah.
and so they have updated the database with some more images, but still it's not comprehensive.
Exactly. Okay. Because the last time when he gets talk here, so till that time it was not available.
No, this is very recent.
Yeah. That. Okay. So the point is, even if we have very limited information. So what is plan? What we thought? Okay. Even if a person want to see that these images, maybe a particular book is better. I think at least he has. But even there, one side image is available. Because if I found interested, I need more context, how it is, what kind of thickness it is, how it's looking like. If I would get those information,
The whole data, that's what I've done, completely cataloged it. So you'll get image proximity data to every script.
yeah. So so you have image, right? But I can't turn your image.
You can.
You can turn. Do you have 3D image?
No, not really.
If not, then I can't turn, right? So that's what I'm saying. So all this plan, is to, can we get 3D images? Okay, and this is the only way that if we can get original access, if we can manage access of original artifact, and we can scan it. What is it? Is it worth enough, or you think your images can do that?
No, the thing is, once you convert the images themselves into data by some kind of tagging, then that information that you're looking for
That is subjective.
it's
that,
redundant.
that's what I'm saying. This is subjective. Here, that's what Mahadevan is saying is two. Brian is saying one.
No, that is a sign list.
That is timing. That's what you said.
That is a sign list problem. I'm not talking about the sign list at all.
Then what are you saying?
I'm talking about the visual component and the proximity of the visual.
You can say that this is what, just in your talk, there was different opinion. Okay, is whether this is a tiger or something else.
No, that's because people have not looked at everything.
You think people are not looking at it, but people might think the different way, right? You should be agree with this way. See, we should have different opinion. You can say this is this, but somebody can say, can't we do?
Why do you think thickness of the sheet will make a difference?
Sorry?
Why do you think thickness of the sheet seal matters?
Oh, I mean, I think I just said thickness. I said if we can get some original image, so like a vase, we can turn full portrait. 3D image will give a broader context, right? 3D image will give at least better context compared to image.
Is it cost effective?
It's very costly, no doubt.
No, is it cost effective to spend so much of resource in doing that?
Yes.
It's likely to get that much significantly more data.
Okay, it is just because, see, once that we will get the contextual information, one. Second, it's even in preservation point of view, we can say that this is um, and we can open to mass, right?
No, no, XRF will give you a lot of data. XRF will be worth that. I'm not
Exactly.
denying that.
Yeah.
If
So
you do XRF of every seal, you will get data which is commensurate to the effort you put in. I'm not denying that.
see, we are going closer to that. So that's what I'm saying. It's right now whatever we have is okay. I'll tell you one major issue because when I started, since I'm working from many years with this data. So sometimes I'm not saying Brian is wrong or Mahadevan is wrong or who is right, who is. Sometimes I want to just as a student or as a scholar, what I want. Sometimes I want to study my sequence into his aspect. Sometimes I like to work on his aspect because I want to try all possible ways.
Actually, there is a third way, which is the font released by Parpola. The font released by Parpola does not make any subjective decision as regards the sign list or classification, and all of them closely mimic the appearance on the object. There is no subjectivity at all in that. It's a straightforward tracing of what is there on the object, and it gives you, instead of 417 or 713 of Brian Wells, it gives you 1839, which is still not a very large number to work with. 1839 is pretty easy to work with. We are talking millions, we are still talking thousands. And it's even possible manually, you don't even need mechanization for it.
We are reaching Chinese now.
Yeah, okay. But I just want to say, see, as a point is, we should, that is true, that okay, they have done quite great job. I'm not pointing out or trying to demonize their work. So I want to say that okay, if we can give access to the original image, original data in original form, 3D form to the mass, maybe they can come up with better idea, right? So see, maybe he is very great. Not maybe, even no doubt on it. Their greatness, I am not doubting on it. I'm saying instead of that, we can give if we can give the whole picture. Okay, so if we can give the 3D data, obviously it will be good. So what is our future plan is we are trying to capture the 3D database. Okay, so then we have planned to make it accessible for everyone, so that people can come up, they can see, they can feel, and then they can study Parpola, they can study Mahadevan, they can study brands. That will be give them they were more contextual information, and which is in our case also. So this right now what we are planning to okay, already we have signed MOU with the ASI, so they are agree to give the access. So yeah, sorry, yeah. So yes, they done. So the point is, now we are on the next phase, that if we manage to do all the basic requirement, then we can. So that will be more helpful. That is our next things, and so this is see already the cuneiform data is already available in 3D form. Maybe I can, if I have. So what? Yeah. So I'll show if. See, this is like this. If we can. So okay, this is not original image. This is what sometime we do. Okay, okay, this is okay. What is this image? Sometime we had a poetry session here, so there we were trying to do it, chasing sometime different kind of stylus, using different kind of what kind of pattern is coming. So we were trying to do this. So this is coming from there. Yeah, I scanned this. Yeah, from that I think this one. This maybe you can just have a look, and so yeah, start a business. It's a part-time job. Yeah, I think I have another. See, this is 3D scanner. Okay. I managed.
These days we get
So that's what we are planning, right? So this is
10, 15
this is another one.
online softwares, we shall merge them into a full 3D image.
Oh,
But the
no,
merger will
actually,
become the
Ashraf,
quality. of the
I'd asked his
production.
vendors to come to show us the 3D scanners.
Yeah.
So he did a test scan.
Test scan. So see, from photography, the issue is the quality is not that great, and even you cannot use one or two photographs. You need a lot of photographs. So that's why we thought, okay, if we'll get access, why multiple photographs? We can get direct scans. That will be the quality will be better. So that's what. Okay, DG asked me the same question. They said, okay, you guys want to do this. What about you know that okay we have a limited resource. I guess I'll first give you permission, then we can convince others. That's fine. Yeah, exactly. Exactly. Yeah. So that's how it is. So the point is, we can. Okay, just 2 minutes. Maybe I. Okay, fine. So yeah, so this is our next plan. So even okay, apart from along with this, we also have planned to host some other databases like close, because we know that okay, Punchmark coin and then Brahmi script and these things, because when we say the competitive study, we used a lot of other inscriptions, but languages, but we didn't manage to do the close one Brahmi things. So that's why our Brahmi's expert here, Nandini, is helping this data curation. So yeah, so this kind of things we have in plan, and almost maybe I can.
If you can do 3D establishments.
Yeah, we. So since Dr. Rehan is here.
Injection molded 3D estampes. Right now, we're all taking 2D estampes. I mean, I've documented Brahmi in 32 sites. I know how difficult it is.
So once we will have the scanner, maybe we can do anything.
3D scanner won't help. That's exactly what I'm trying to say.
Okay.
You need injection mold, rubber injection mold, and take it out, and then so you get it with the depth.
Okay.
So that's a different technology. It's not 3D scanning technology at all. You can take a 3D scanner to those sites.
Will they allow?
You can do that. You can do that. You can.
Well taken. Maybe with next plan we can add it in our plan.
So basically, what we do today is we put a paper on top of that.
Maybe I will just finish at least then this will, we can, otherwise our tea will be our.
Someone will.
Yeah, so this is our database. So how we have planned, because anyway this is running in my computer, so it's a little where is database like so where is data punchmark okay, this is the punchmark thing. We can, yeah, so these are the right now I have added only single sequences into the just two. So these kind of things we are trying to make the database. So we have okay here, but our main focus is to just get this sequence. That's why I was asking whether how to start, because we have started just based on the Hardiker books. According to, maybe I'll talk with you regarding these things, and yeah, especially so again, so we also have assigned some specific number to each signs, the way it is done, the usual convention. So so yeah, these things we are in the pipeline, we are doing. So maybe within a month you will get all these data online. It's for free, anybody can have access and you can work on it. Okay, for Brahmi things, Brahmi things, our data will look like, in the term of data, it will look like this, where we have assigned numbers to each sign. We also have added different markers, so that a person, if a person want to consider, okay, because we know that okay is alpha syllabary system. So if you want to consider just alphabetic way, you can use, you can consider this conjunction notation, and you will consider in that way. If you will omit this, you can consider in the alpha syllabic way. It's like this. Suppose if I tell you, so where is that? Let's say in Hindi, if anybody wants any word, ghadi. This is ghadi. So this is one letter. This we can is a joint form. So this joint form we have added into this with star mark. So we have advantage in our database is that, okay, if you want to consider these as a joint, you can you can deconsider, reconstruct. So whatever way you want, up to whether you want to split into the lowermost level or highermost level, based on the sentence marker, you can use all these things. So yeah, so that's how we are working. But yeah, so thank you. So thanks.